Hello, I know that you guys are, or well, some of you are having a little bit of trouble with IUPAC nomenclature. So in this video, we're going to be going through how to name things, especially from drawing to an IUPAC name. So let's go through some rules for IUPAC nomenclature. So the first thing we want to do is find the longest chain, which is pretty easy, right? Second, you identify your substituents. Then, most importantly, third, you want to count so that the substituents are on the lowest locant. Locant meaning the carbon that the substituent is on. Then, after you get all that information, you want to alphabetize your substituents. But you do not alphabetize multiplicative prefixes such as di, tri, and tetra, like a dimethyl or a trimethyl, as well as a few substituent modifiers such as sec or tert, like sec-butyl or tert-butyl. But you do count iso, neo, and cyclo. Our naming formula that we're going to use is a number, comma, number, dash, substituent, and if you have another substituent, you would follow that. Same thing right there, plus the parent name. So for example, 2-chloro-3-methyl pentane right here. So we have our chloro or chlorine on carbon 2 and our methyl on carbon 3, as well as our 5-carbon chain. And then we have, I don't know if that's actually visible right here. So we have that 5-carbon chain and then chlorine on carbon 2 and then methyl on carbon 3. And our second example is 3-bromo-2, 2-dimethylbutane. And we can see that it's a 4-carbon chain, so that's butyl, butane. And then we have a dimethyl at 2 and a bromine on carbon 3. You could count that chain the other way, but I'll explain that in a little bit. As you can see in the names as well, the dashes are separating the numbers from the letters, and the commas are separating the numbers from the numbers. All right, so let's get our practice in. Okay, let's start off with number 1. We can see that we have a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is our longest carbon chain. And so we need to find our substituents first, or second. I can see that we have a methyl here and 2 other methyls here. So how can I count the carbon chain then? We can count 1, 2, 3, 4, 5, or we can count the other way around. But here's the tricky part. Our substituents are on equal sides, or if we count the other way, or on both sides, we can count 1, 2. So going either way, there's a substituent on carbon 2. So how do we differentiate? Well, we always want to count so that the substituents are always on the lowest locant, or the lowest carbon, right? So let's compare how we count on both sides. If we count left to right, then we have a methyl on carbon 2, a methyl on carbon 2, and a methyl on carbon 4. If we count the other way, then we have a methyl at carbon 2, a methyl at carbon 4, and another methyl at carbon 4. These differ by 1 point. And referring back to our third rule, we want to count the chain so that the substituents are on the lowest number. We want this top one. This is called the point of difference rule. So, based on that rule, we want to count 1, 2, 3, 4, 5. You can see that. And kind of see that a little bit clearer. Okay. So we have a trimethyl because in total we have three methyls. we want to separate those locants by commas. Because there's 3 methyls in total, trimethyl pentane. Notice that the locations are separated with commas, and the substituent and the locations are separated by the dash. Going to the second one, find the longest chain. We can count 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Okay, 7. 1, 2, 3, 4, 5, 6, 7. That could be another way. But does it really matter? Let's see. 1, 2, 3, 5, 6, 7. 1, 2, 3. So we have an ethyl in carbon 3. 2, 3, 4. 1, 2, 3, 4. No, it doesn't really matter. But now we have another problem. Going from left to right, we have an ethyl, a methyl, and another ethyl. Going from right to left, we have a methyl, ethyl, and another ethyl. So, let's number 1. 1, 2, 3, 4, 5, 6, 7. Right? We have a methyl, an ethyl, and another ethyl. So, what direction do I count from? I can count from the left to right to left, but we have a substituent on carbon 3 if we go from left to right, or again carbon 3 from right to left. That's when we need to alphabetize. So we know that this is an ethyl and this is a methyl. The way I want to count is, okay, what letter comes first in the alphabet? E, M. E beats M by a landslide. So I'm going to count 1, 2, 3, 4, 5, 6, 7, on from left to right. Okay. Let's see. So we have an ethyl at 3 and 4, and a methyl at carbon 5. So 3, 4, diethyl. Again, we're not alphabetizing the multiplicative prefixes, but it just so happens that diethyl just comes first. Then we have a methyl at carbon 5. Methyl heptane. Okay. Can you see that clearly? A little bit. That's a little bit better. Okay. Third one, we have a 1, 2, 3, 4, 5, always counting the longest chain. But we can also count the other way. But let's know. 5 equals pentane. And we have a chlorine and 2 methyls. Right? We could alphabetize, seeing that C goes first in M, but we still want to abide by the lowest locant rule. So we could count 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, right? We only use the alphabetical ordering rule from the last problem if the point of difference kind of fails us, right? Because in the last problem, we didn't have a point of difference to make. It was kind of symmetrical in numbering terms. So we have to resort in alphabetical ruling. But we can clearly see that if we number from 1 left to right, we get a chlorine at carbon 2 and a methyl, 2 methyls at carbon 4. But if we go the other direction, we get 2 methyls at carbon 2 and a chlorine at carbon 4. They both differ at that point, and so the lowest numbering will win. So we take this numbering from right to left rather than left to right. So our official numbering for this molecule will be 1, 2, 3, 4, 5. And so now we have our information, we just need to put it together for a name. So we alphabetize. We have 4 chlorine, 4 chloro for the halogen. If I had a bromine there instead of a chlorine, we would say bromo, or if I had an iodine at carbon 4 instead of a chlorine, I would say iodo, okay? So halogens end with oro, chloro, bromo, iodo, fluoro. Okay. Then we have our 2,2-dimethyl pentane. Here we go. Alphabetical order, lowest numbers, lowest locant rule, and yeah. Okay. Let's work on this one. I'll work on that one. Okay, number 1, number it. Sorry, find the longest chain. We have 1, 2, 3, 4, 5. Doesn't really seem the longest. We have 1, 2, 3, 4, 5. What about this one? 1, 2, 3, 4, 5, 6, 7, 8. That's way longer than 5. But what about the other way? 1, 2, 3, 4, 5, 6, 7, 8. Does it really matter? Absolutely. We have a methyl here, and this huge group, an isopropyl. And a methyl. So, which direction should I be numbering? Well, again, I want the substituent on the lowest locant. If I counted 1, 2, 3, 4, then my isopropyl will be at 4. But I can beat that by counting the other way around. 1, 2, 3, 4. Okay. Wait, 1, 2, 3, 4. 1, 2, 3, 4. I lied. Okay. So the lowest locant rule fails us, meaning we have to rule it or order it with alphabetical ordering, right? Iso versus methyl. I versus M. Iso wins because it comes first in the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N. Okay, yeah, I'm not sure. Okay. So, iso wins, so we go this way. 2, 3, 4, 5, 7, 8. Okay, 1, 2, 3, 4. Okay, I'm not sure. So, make that 5 a bit clearer. Now we have to put all this information into a name, right? We have our 4 isopropyl. We are going off of alphabetical ordering. 5 methyl. And since it's an 8 carbon chain, it's an octane. So our final answer is going to be 4 isopropyl, 5 methyl octane. Okay. Okay. And for the last 2, let's go for number 5. We can count the longest chain. 1, 2, 3, 4, 5. What about the other way? 1, 2, 3, 4, 5, 6. So it seems like counting this chain this way gets our longest chain. So we then identify our substituents. A methyl and a bromine atom here. Let's see if the lowest locant rule helps us at all. We can count 1, 2, 3 to meet our first substituent, or we can count 1, 2, 3, meeting our first substituent here. Seems like the lowest locant rule kind of fails us again, so we have to alphabetize. Bromine versus a methyl. The B in bromine wins by a landslide in the alphabet versus the methyl, which starts way later in the alphabet. So we count this way. 1, 2, 3, 4, 5, 6. Okay? 3 bromo, again, ending in mo, or well, ending in o, I guess. Chloro, bromo, iodo, fluoro. 3 bromo, 4 methyl. Hexane. Okay, so just to reiterate, we couldn't count this way, we had to count that way because if we counted either way, our substituents land on carbon 3, right? So that doesn't really help us at all, so why not count this way other than the other one? The point of locant rule sometimes doesn't really explain why we count one way or the other. When that fails, we resort to alphabetical ordering, which in here, bromo goes first because it starts with a B, rather than methyl because it starts with an M. So our final answer is 3 bromo, 4 methyl hexane. Okay? But our last question or problem here, we have a ring. Your ring says to us that, hey, I start, or this is a cyclo something, a cycloalkane. Ring equals cyclo. So we have to put cyclo in the name. Okay? But our first rule says to find the longest chain. What if I had something like this, where my ring is 6 members, but my alkyl chain, 1, 2, 3, 4, 5, 6, 7, is 7 carbons long? Which one wins? Again, find the longest chain. If the longest chain is the carbon, we're going to base our name off of that. Wait, what? If our ring is a 6-membered ring, then we would base our answer based off that ring. If our alkyl chain, this one, is more than 7, then more than 6, we will then base our answer off the alkyl chain. Here we have a 6-membered ring, and if we count here, we would have 1, 2, 3, 4. We only have 2 methyls right there, so in fact, the ring wins the first rule. But why can't I count 1, 2, 3, 4, 5, 6, 7, 8? That's way longer than 6, right? But the problem is, if I were to count like that, then I couldn't really classify that in my naming. I don't really know what that is, right? It's either the ring or just the alkyl chain. So, since the ring beats an alkyl chain by having the longest chain, we're going to base our answer off the ring. I could count 1, 2, 3, 4, 5, 6, or I count the other way. Let's see. Let's look at our substituent. We have a sec butyl, and we have 2 methyls. We don't need to resort to alphabetical orders yet. Let's try the point of difference rule. What if I counted 1, 2, 3, 4, 5, 6? Then I would have 1, 1. Can you see that? I'll take it a bit longer. 1, 1, 4, because I have a methyl at carbon 1, another methyl at carbon 1, and then a sec butyl at carbon 4. What if I went the other way? Then I would have, let me erase that. What if I counted the other way? 1, 2, 3, 4, 5, 6. Then I would have a sec butyl at carbon 1 and a methyl at carbon 4 and a methyl at carbon 4. We can see that the point of difference helps us to differentiate between those two numberings. We have to number this way, starting at the methyl, because it gives us the lowest locants. See, 114 versus 144, they differ at that point. So this top one was 96. Yay, happy days. Okay, let's start numbering. 1, 2, 3, 4, 5, 6. Right? We have a sec butyl at carbon 4 and a dimethyl at carbon 2. Going off of our rule for alphabetizing our substituents, this rule, we exclude any multiplicative prefixes when we alphabetize, or any substituent modifiers such as sec and terp. So we have to base our alphabetical ordering based on the B in butyl and the dimethyl and the M in dimethyl. So B goes first over M. So this, our final answer is going to be 4 sec butyl one dimethyl cyclohexane. There we go. 4 because we have the sec butyl. We also keep the dash between the sec and butyl. Don't ask me, I don't really know why, that's just convention. 1 a dimethyl at carbon 1 and a cyclohexane, because it's a ring and the hexane means that the ring has 6 members. Alright, so I hope that helps with nomenclature, clearing up any confusion. Let me know if you have any more questions. I'm always happy to help. Good luck. Bye.